We're continuing on in Unit P, our first unit, with more preliminary things that we should be recalling from pre-algebra and Algebra 1. Today we're going to be talking about polynomials and making sure that we know all the terminology and proper terms to use when discussing mathematics. So we're going to start with a term. What is a term in math? A term is an input to addition. So what does that mean, input to addition? Well, it contains variables and or constants, so letters and numbers, and they are connected by multiplication and division, not addition and subtraction, multiplication and division. So recall, a monomial is one term, monomial, one term, and again, it can be variable or constant and a variable, coefficient and a variable, connected by multiplication, multiplication and or division, multiplication. So those are each examples of one term. Binomial, two terms. Again, those terms are connected now by addition or subtraction, so one term, two terms, connected by addition in this case. There are two terms. There are two terms. Trinomial, three terms, connected by addition or subtraction. And a polynomial is more than three terms. And where that comes from is well, it's Greek. So the word poly in Greek means many. And the Greek word onoma, so there's a Greek word, onoma, which is name. So nomial comes from the Greek word for name. Now, an algebraic expression is a polynomial in a single variable if and only if it can be expressed in this general form. Now, maybe the first time you see this, it'll be a little overwhelming, but we'll make sense of it, we'll utilize it, and it'll hopefully make a lot of sense very soon. So let me go ahead and write the general form for a polynomial in a single variable x. So I have x to a power, some power n, and it has a coefficient. So a sub n times x to the n is just saying that I have an x term raised to the nth power, and to denote the coefficient for that power n of x, I have a subscript n. And then in general form, we write it in exponentially descending order. So the next lower term is going to be one power less, and it's going to have a coefficient that corresponds to it. And that's going to go all the way to, let's say, I have an x squared term that has an coefficient, a sub 2, and then a sub 1, x to the first power, and then a naught, x naught. So that's just a constant. So again, I don't need to see this. I don't need to see this. I technically don't need to even see this part of the last constant term because this is just a constant term. And I have to specify where these little coefficients, these a sub n's, n minus 1, down to a sub 2, a sub 1, a naught, are just elements of the reals. They're just real numbers. A sub n, this leading term cannot equal 0, or that whole term doesn't exist. And the n's that I'm referring to are just elements of the set of whole numbers. So if I give you an algebraic expression, the first thing you're going to want to do is put it in standard form. Okay? So to write it in standard form, we're going to write it in exponentially descending order. So we want those exponents to go from largest to smallest. So I'm going to take this algebraic expression, which is a polynomial, 1, 2, 3, 4, 5 terms connected by addition and subtraction. All the terms are in the variable x. And the first thing I'm going to do is put it in standard form. Work with anything, I want to put it in standard form. So let's rewrite this in exponentially descending order, in standard form. So in standard form, the first term, with the highest exponent, is right there. So I'm going to rewrite this as negative 4x to the 5th. The next highest exponent is 3, so plus 7x cubed minus 5x squared plus 3x minus 6. So now I have it in standard form. Now let's go ahead and talk about some components. How many terms does this polynomial have? 1, 2, 3, 4, 5. Do we have any like terms? Or no, let's go ahead and list the terms. The terms are those separate little pieces, expressions, monomials connected by addition and subtraction. So there are my 5 terms. Are any of them like? No, or we'd combine them. So we would say that this is a 5-term polynomial. Now the degree of the polynomial in one variable is the exponent of the variable in the term. So the degree of a term is just the exponent. So what is the 4th degree term? The 4th degree term in the polynomial, well, I don't see one. There is none. There is no 4th degree term. What about the 0th degree term in the polynomial? The 0th degree is x to the 0 power. Well, we know that's connected to the 6, because x to the 0 power, if x is not equal to 0, then that equals 1. So the 0th degree is negative 6. And this is, again, called the constant term. Now, the degree of the entire polynomial in one variable is the highest degree. So the degree of highest degree term. So the degree of the entire polynomial is 5, the largest exponent. The coefficient is the numerical factor of the term. What's connected to the variable by multiplication? So what are the coefficients in the polynomial? The coefficients in the polynomial, negative 4, 7, negative 5, 3, negative 6. And we do want to take the operation with it. The leading coefficient, so the coefficient of the highest degree, is negative 4. Ooh, I already answered that question. It's the coefficient of highest degree. Now, what is a factor? A factor is an input to multiplication. So polynomials in one variable are named by their degree and the number of terms. So when you're naming or classifying the polynomial, you have to state its degree and how many terms it has. So what is the name of this polynomial? It is a 5th degree 5-term polynomial. So we say that a polynomial is classified, is named by its degree and the number of terms. Let's talk about the proper language that we would use for the differing degrees and the differing of number of terms. So if I have a degree 0 term, I'm dealing with a constant. It's just a number. If I have a 1st degree term, then I'm thinking, for example, x to the 1st, and we would call this a linear term. So x, 4x, x plus 5, those would all be linear. The highest power of x is 1. What if the highest power of x is 2? We would call that quadratic. So maybe 2x squared plus 7, that would be quadratic. The highest degree of x is 2. What if the highest degree of x is 3? We would call that cubic. That would be an example of a cubic polynomial. And what if the highest degree is n? We would just say that it's nth degree. So whatever that n may be. Now, you also classify and name it according to the number of terms. Well, if you have no terms, you have no algebraic expression. If you have one term, we said it was a monomial. And remember, that could be a constant, it could be a variable, or a constant and a variable with a power, but it's connected by multiplication. If it's 2 terms, we said it was a binomial. Example, x squared plus 3. 3 terms, we said it was a trinomial. I don't care about the degree, I care about how many terms it has. And if it has m terms, I would call that an m-term polynomial. So again, to classify a polynomial, I have to include what the degree is and the number of terms. So, given a polynomial, first thing you want to do is put it in standard form. So if I were to rewrite this in standard form, highest degree is 2, so 5x squared plus 4x plus 3. That's standard form. The leading coefficient is -5, and that's why you want to make sure you put it in standard form first, exponentially descending order, so you don't accidentally just take the first term. You take the first term if it's written in standard form. The degree, highest exponent, is 2. The number of terms, 1, 2, 3. So if I were to classify that polynomial, I would again state the degree and the number of terms. So I would call this a quadratic because the degree is 2. And then I have 3 terms, so that would be trinomial. So this would be a quadratic trinomial. Next example, try it, see if you can get it. Put it in standard form, identify the information, and let's check our work. Feel free to pause. Do it yourself. 8x to the fourth plus 3x squared minus 4. Leading coefficient, now that it's in standard form. Degree, highest exponent. Number of terms, 3. Classification, fourth degree. Trinomial. Now, if I want to add and subtract polynomials, I have to have like terms. So in this first example, I see a binomial plus another binomial. So I can just drop the parentheses because it's addition, and I'm going to combine like terms. So I have 2x plus, well, I'm going to go ahead and rewrite it. You don't have to. So I'm going to combine my x terms. I'm going to combine my constants. And then if I actually combine them, I'm going to get negative 5x minus 2. And that's my final answer, because I can't combine them. Those aren't like terms. Next one, I have a third degree 4-term polynomial plus a cubic trinomial. And it's addition, so I can just combine like terms. So I have x cubed, so that's negative 6x cubed plus 17 x cubed, and then I have squared terms plus 5x squared plus 2x squared, and then I have x to the first power, negative 8x minus 4x, and then I have a little constant I can't forget. And if I combine those, what am I going to get? I'm going to get 11x cubed plus 7x squared minus 12x plus 9. Final answer. Oops. Let's try that again since I kind of wrote over that. There we go. Final answer. Can't combine anything, anything else. Oh, and let's classify this. The first one would be a linear binomial. Final answer, cubic 4-term polynomial. Might as well. Now, what if I'm multiplying binomials? Well, if I'm multiplying binomials, I'm just foiling. So, again, review first, outer, inner, last. So we should be able to remember first, outer, inner, last for multiplying binomials. Let's use the distributive property. Feel free to work these on your own and check your answers. Distribute. Then use your property of exponents. 2x times x to the fourth plus 2x times negative 5. So that's giving me 2x to the fifth minus 10x. Final answer. Let's go ahead and now distribute the 2x to each of these. So that's, I'm going to do it all at once. 2x cubed minus 8x squared plus 6x. And now I'm going to distribute the minus 1. So that's minus x squared plus 4x minus 3. Now I need to combine like terms. So I have no other x cubed terms, so that's 2x cubed, but I do have 2x squared terms, so minus 9x squared. And then I have 2x terms plus 10x, and then bring down the minus 3. And I'm done. Let's FOIL the next one for practice. So I have 21x cubed plus 6x squared plus 28x squared plus 8x, combine like terms, 21x cubed. I can combine these to get 34x squared, and then don't forget the plus 8x. Now, we talked about conjugates and conjugate pairs, and hopefully you remember that the product of conjugate pairs is the difference of two squares. So we talked about that when we were talking about rationalizing the denominator. So these are conjugate pairs. The first term and the last term numerically are the same, but the connecting sign is they're opposites. So if I were to FOIL that, I'd get a squared minus ab plus ab minus b squared. These go away. So the difference of two squares, remember that. Are these conjugate pairs? Yes, they are. In this case, a is 2, b is y to the 5th. So I would have a squared minus b squared, so that would be 2 squared minus y to the 5th squared, which is 4 minus y to the 10th. Difference of two squares. So squaring binomials, whether it is sum or difference, in this case, oops. In this case, I have a plus b squared, so that's times itself, which gives me a squared plus ab plus ab plus b squared, so that's a squared plus 2ab plus b squared, versus a minus b times a minus b, which is a squared minus ab plus b squared. So that's a squared minus 2ab plus b squared. So what I want you to notice is that if I have a sum, these are all positive. If I have a difference of two terms squared, then the first term is subtraction. The second one is addition. So notice the coefficients are the same. The coefficients are the same. I have the coefficient here, 1. I have the coefficient here, 2. I have the coefficient here, 1. Coefficient 1, 2, 1. The difference is this is plus, plus, and in this one I have minus and plus. So numerically speaking, we have the same coefficients. The signs are different. So in this case, I can identify A and B again if I wanted to. I could say A is X, B is 5. So I could go ahead and just substitute A and B in there and check it by FOILing. See if it works. It should. It will. Plus 5x plus 5x plus 25. So that's x squared plus 10x plus 25. Does that work if I substitute in A and B? A squared plus 2 times A times B plus B squared. Yes. So, you know, you can actually do the multiplication, or you can remember these little coefficients and just learn these, and that would be helpful. Now, what if I'm cubing binomials? Cubing binomials, well, I would be multiplying this binomial times itself, repeating the multiplication 3 times. So I could leave the first one alone and then FOIL these. So if you already know it, it makes it easier. And then distribute. And distribute again. And let's see what that would give us. That's going to give us a cubed plus 2a squared b plus ab squared plus ba squared plus 2ab squared plus b cubed. And then I would combine like terms. So let's look at our like terms. I have a squared b, a squared b. So I'm going to bring down my a cubed. I'm going to combine my a squared b. The commutative property of multiplication says that that order doesn't matter in the multiplication. So I have 3a squared b. And then I'm going to combine my ab squareds. And then I'm going to bring down my plus b cubed. So this is another good one to know. And again, since this is a sum, these are all addition. This is a difference, so let's see how that's going to compare. If I were doing a difference, I would have, and maybe you can kind of hypothesize what the final result will be. And then distribute. So combine like terms, a cubed minus 3a squared b plus 3ab squared minus b cubed. Did you think that's what it would be? This is a subtraction, so subtraction, addition, subtraction. Notice those coefficients. 1, 3, 3, 1, 1, 3, 3, 1. Since this is addition, these are all addition. Since this is subtraction, we alternate. So if I were to look at this example, if I were to identify A and B, I could just substitute into this a cubed plus 3a squared b plus 3ab squared plus b cubed, a being x, b being 5, and I'm going to get x to the 5th plus 15x squared plus 15x squared. Oops. Sorry. That is 75x. If I multiply these, that's going to give me 75x. Got ahead of myself. Plus 125. And that is an exponentially descending order. Now, this squaring of binomials and squaring of and cubing of binomials, the reason I wanted you to pay attention to those coefficients is because you actually don't have to do the multiplication. If you can identify the A and the B, and you can generate what is known as Pascal's triangle, which is for different powers of a binomial. So in other words, this is a plus b to the 0, which equals 1. A plus b to the first is just a plus b, 1, 1. A plus b squared is a squared plus 2ab plus b squared. 1, 2, 1. Notice these. This is a plus b cubed, which is a cubed plus 3 a squared b plus 3ab squared plus b cubed, 1, 3, 3, 1. These coefficients of a binomial raised to a different increasing integer powers is easy to generate. So Blaise Pascal, a French mathematician, came up with this and said, well, I'm going to start with 1. And I'm going to bring that down. But what I'm going to do to generate each row in Pascal's triangle is to add the two immediate terms above. So 1 comes down to 1, 1. 1 comes down. 1 plus 1 gives me the 2. 1 comes down. 1 comes down. 1 plus 2 gives me the 3. 2 plus 1 gives me the 3. 1. So what would the next row be? The next row, well, I'd bring down the 1. I'd bring down the 1. I'd add these to get 4. Add these to get 6. Add these to get 4. And those would be your coefficients if I have a plus b to the 4th. So it would be a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. So that's where these coefficients come from. And a exponents decrease as b exponents increase. So the next row would be 1. Add these two together, I'd get 5. Add these two together, get 10, 10, 5, 1. And those would be the coefficients if I were to raise a plus b. And so on and so on and so on. So you should be able to generate Pascal's triangle. Many, many rows of Pascal's triangle. Or given a row of Pascal's triangle, you should be able to generate the next row. Okay, in this case, I want to combine like terms again. So I'm going to start by bringing down the first polynomial, 5x to the 4th y squared plus 6x cubed y, well, it's cubed, minus 7y. And then I'm going to distribute this minus sign ever so carefully, minus 3x to the 4th y squared plus 5x cubed y plus 6y minus 8x. Then I'm going to combine like terms. Well, I don't have, oh, I do. There we go. So 2x to the 4th y squared. And then I'm going to combine plus 11x cubed y. And then I'm going to combine my y's, minus y, and then minus 8x. And this is in standard form with respect to x. The x's, oh no, it's not. These two should be reversed if that was in standard form. So standard form with respect to x would be 2x to the 4th y squared plus 11x cubed y minus 8x minus y. So that's standard form with respect to x. But if I don't specify, it doesn't matter. Okay, now let's do the next one. Let's go ahead and multiply this binomial times this trinomial. So distribute the x. So x cubed minus x squared y plus xy squared. And then let's distribute the y. Plus x squared y minus xy squared plus y cubed. And then let's combine like terms. So I have x cubed, and then I can these cancel each other out. Lovely. Ooh, these cancel each other out. And I'm left with y cubed. Lovely. Go ahead and try the next one. The next one's tough, but you can do it. You will have to distribute this to every single term. And then you'd have to distribute this to every single term. And then you'd have to distribute this to every single term. So try that and see if you get the right answer. I'm not going to say anything. Pause it. I'll work it out. See if you get the right answer. Okay, I've distributed everything. Now I'm going to combine like terms. Oh, and there's your final answer. So see if you can get that.